today we're doing preparing a proof. So all this stuff we're doing with logic this chapter and dealing with triangles and different things is trying to help us to prepare for proofs. So trying to get us ready for those proofs. So today we're going to see what a two-column proof looks like, a paragraph proof looks like. There are 5 parts to a proof on the bottom of page 194 that I'm going to put up here so you can kind of check that out. Okay? So proofs, we're going to try to start making conclusions from pictures and diagrams. Not a bit, but let's take a look at this. That's page 194. There are 5 parts to a proof, and this is a two-column proof. This is what we're going to be doing a lot of this year. We don't really do any paragraph proofs all that much, or flow proofs. So we'll use a lot of two-column proofs. So go ahead and that's kind of blurry. Much more blurry today than it has been in the past. Let me see if I can focus it by hitting that. There, I don't know if that helps. Not so much. But do your best there. Okay, copy that down. It's also on page 194 if you want to reference that. But copy down those parts. Be down here in a while. But the parts of a proof, page 194 there. Okay, we have our given. We have what we're trying to prove. A lot of times you already have the picture. And then we have 2 columns called statements and reasons. And our statements just say, they give a logical statement, and then you have to provide a reason for that statement. And some of those reasons might be like, maybe say triangle ABC is congruent to triangle XYZ, and the reason could be triangle angle sum theorem. Okay? So a lot of the proofs and different things, theorems that we're using early on and coming up with, we're going to use in proofs later in the year. All right, so let's talk about some theorems here. Theorem 4.4, 4.5, 4.6, and 4.7. There we got it. These are on page 135 or 195. Some of them you already know, and they're like duh statements because you've dealt with them before. Some of them you may not have heard. Okay, let's check it out. 4.4. Let's try to draw a picture of each one of those there. Okay. If a triangle is a right triangle, then its acute angles are complementary. Okay, think through it. Try to draw a quick picture. You get about. So if a triangle is a right triangle, so I'm going to draw a right triangle. Okay, then its acute angles are complementary. Well, we know in a right triangle we already have one angle that adds up to, or that measures 90. So that means if all the angles of a triangle measure 180, and you subtract the one that measures 90, what are you left with? You're left with 90. Therefore, this angle and that angle have to add up to 90. That's the remaining after you take off that 90. Okay? How many knew that? How many like you get it and you probably knew it, but you didn't know you knew it? Yeah, I mean that's just the case. So these two things just have to add up to 90 if you see that right angle there. So some of you use the triangle angle sum theorem where they all have to add up to 80, but you could really just say those are complementary. Remember, complementary starts with the letter C, and those add up to 90. You draw that line. So complementary starts with the letter C. If you draw a line, you get that 9. Okay? All right. 4-5, 2 angles of one triangle are congruent to 2 angles of another, then the third angles are congruent. Go ahead and draw a picture of that real quick. Notate it. You get about a minute there. All right. So I'm going to use this triangle. And I'm going to use this triangle. And I'm going to label this triangle ABC because I'm creative like that. And I am going to label the other triangle
ABF.
X, Y,
C.
J. Just because I can. Okay? And I'm going to make my J look like that even because I'm cool. Okay? I can't use A again because A is over here. All right, so let's say triangle ABC. Okay? And we have triangle XYJ. And now let's say I know that angle A is congruent to angle X. Okay? Those are congruent. I also know that angle B is congruent to angle Y. Those are congruent. Okay? How do I know then like this theorem stating, how do I know the third angles, angle J and angle C, are congruent? How do we know that? That's what this theorem's stating. Diamond?
Well, like after you add the two measurements of the angles, the difference between that and what you do, both triangles are the same.
Well, that's good. Yeah, when you add these two angles up in this angle or in this triangle, let's say those two add up to, let's say that's 30 and let's say that's 50. Okay, which makes that one 30 and that one 50. The difference from 180, if you subtract these two, okay, minus 80 in this case, is going to equal 100, which is all we have left over for C. And the same thing here, 180 minus the 80 equals 100, which is all we have left over for J. 100 equals 100, therefore these two things are congruent. That's a true statement. Okay, good description there. 4.6, I'm not going to go into great detail, but all right angles are congruent. Now, that may seem obvious, but we've got to use that statement. Okay, and 4.7, if two angles are congruent and supplementary, then each is a right angle. Okay, so if two angles are congruent and supplementary, so let's say a straight line, that gives me supplementary angles, right? Remember, supplementary, add up to 180, you draw that line and you get an 8. So you have the letter S for supplementary, you draw the line and you get the 8. Versus the complementary, you have the C, you draw the line, you get a 9. Complementary is 90, supplementary is 180. But if two angles are congruent and supplementary, so there we've got it. This is congruent to that, and they're supplementary angles because they make a straight line. Therefore, 180 divided by 2 is 90. All right. Cool. All right. Well, seems like we got it. Here you go. You guys are doing those. All right, Logan, number 1. What can you conclude from that diagram? All the angles are congruent. Anyone agree? Okay, what else can we conclude from number 1? All angles are congruent, Logan says. Can we conclude anything else? Yes, Bethany? Okay, all angles are 90 because they're right angles. All right, anything else? So all angles are congruent. So if you're writing that, by the way, you can just write it like this. Except for make sure that's congruent. All right, you say all angles. Once again, you can put A equals angle B, which equals angle C, which equals angle D, equal 90. Okay, it's the right angle markings. Yeah? All square. No, I can't say that, but you're close to something. So first of all, it says, what can you conclude, and then justify your answer. So how can we conclude this, Logan? Okay, well, the same marking. What is that marking? Okay, they all add up to 90 degrees. Okay. All right. How can we conclude this one, Bethany? Yeah, in fact, up here we should say they're all right angles. Okay, and here they're all right angles. And all right angles equal 90. That was one of our theorem. Okay, Carson, you're really close. What shape is this? Maggie? This is a rectangle. ABCD is a rectangle. Now, how do we know it's a rectangle? Go for it.
Because it says the sides are congruent, we only know that it has 4 right angles and 3 left angles.
Good, 4 right angles. Okay, has 4 right angles. Now we know it's not, we don't know it's a square because the sides doesn't show they're congruent. So usually we'd say that by definition, but for right now we're saying it has 4 right angles. That's a definition of a rectangle. It's a quadrilateral with 4 right angles, so we should probably list quad there also. Quad with 4 right angles is a rectangle, by definition of a rectangle. Number 2, what can we conclude right there, Ethan?
Number 2,
Yeah, man.
that it's a right triangle
It is a right triangle. How do you know?
because there's one right angle in
Okay, EFG is a right triangle because of, as angle E is a right angle. Okay, right angle. Okay, what else do we got there? Zach?
F and G are complementary.
F and G are complementary. How do you know? Okay, so we don't want to just say theorem, but you're right. We did cover a theorem on that. How do we know that F and G are complementary? Go ahead, Emma.
Because there's a right angle, and then if you take the angle sum theorem, and you take 90 minus 90, that means F and G come at a triangle. Are we not doing that?
What's up?
F equals 60.
F equals 60?
Yeah, because it's 90 plus 30, which is 120. You go to 180.
Oh, wow. So that's another one?
Yeah, but that means that angle G and F are not like, oh, I don't know, it's like a congruent. Yeah.
But you're right. F is equals 60.
Yes.
Okay, F equals 60. How come?
Because they are complementary, and that means they have 90.
Good, and we use this a lot. Triangle angle sum theorem. In fact, you can abbreviate it like that. Triangle angle sum theorem. That's all you have to say there. All those have to add up to 180. We could also say angle E is what? Equals?
Angle F and then
James? 90 degrees, yeah. All right angles equal 90 degrees. I know that seems obvious, but it's something you have to add in your proof there. All right?
You just put all of this in when you're
Well, I'll tell you what we need to put here in a minute. Yeah. Okay? But for now, that's what we're putting. Number 3, what do we got? Someone new? Yes, Haley?
angle DBA and angle ABC are congruent.
Angle DBA is congruent to angle B, or hold on,
ABC.
ABC. How come?
Because they have the congruent lines.
Okay. So that's kind of a given, right? So we could say given there. So we're really not concluding it, but we're going to put it right there. Okay? Yeah.
angle DBA and angle ABC are supplementary.
Okay. Angle DBA and angle ABC are supplementary. Cameron, how come?
Gonna say something else.
Oh, okay. How come? Yes.
Angle DBA is 90 degrees and ABC is 90 degrees, so they're congruent.
How do we know they're 90?
Oh,
I'm kind of being difficult here. All right, you're right, but go ahead, Chase.
They're 90 because it's on a straight line and the angles are congruent.
Good. Remember the theorem. Theorem says congruent supplementary angles are equal to 90 degrees. So all we have to say are, and we can abbreviate it, they're congruent supplementary angles. That's all we have to say. They're congruent supplementary angles. We have a theorem for that. Okay. Now, what do I expect? I don't expect you to write all this stuff down. I want you to find at least 2 things usually that you can conclude. Okay, when it says what can you conclude, try to find 2 things. And usually the things can't be given things. So like this one, there's not a lot to conclude. Really, there's only one. We have the given here. Okay, but really there's only one big one. I guess you could say, I guess actually you know what you could say, just like Emily said there, you could say DBA. So I take that back. And angle ABC equal 90 degrees. Okay, they equal 90s because they're congruent supplementary angles. All right. So congruent supplementary angles. Any questions there? Let's take a look at numbers 4 through 6. 4 through 6. Woohoo! What can we conclude from each diagram? All right, go ahead. Let's do 4. Actually, you guys try 4, 5, and 6. Come up with 2 things on each. Get about 3 minutes. Okay, give me one thing for 4. I know you haven't quite finished the others. Go ahead, Grace. Okay, so angle Q and angle, so you're talking about this angle? And this angle are complementary? Is that what you said? They equal 90, yeah. Okay, so we want to label that as RQG and QGT. Are complementary. What reason did you give?
Because of the triangle involved in the theorem.
And angle T is a right angle. So you'd have to add that piece in. Angle T is a right angle with the triangle angle sum. Good. What else? Haley.
Is there angle R is congruent to angle RG or RQ and is also congruent to QGR?
Good. So you have 3 congruent angles. Yeah. Okay. This angle is congruent to that angle, congruent to that angle. How come?
There was one theory, or theorem, but I don't remember what it was. But it was one that was like all equilateral triangles, equal angular.
Yeah. Equal. If it has equal sides, then it's equiangular. So this triangle, we can actually conclude that triangle RQG is
Equilateral.
equilateral by definition of an equilateral triangle. What angle can we figure out up there? Olivia? So like this one? So we got a Q or GQT is? Yeah, how do you know? Good, and we say triangle, angle sum, theorem. You guys get used to saying that. You're going to say it a lot this year. It's just the triangle angle sum theorem, saying that this plus this plus this have to add up to 180. That's all that says. Okay. We're almost out of time, so your assignment today is the example side. The example side. Okay, yeah.
Number 7.
Uh-huh.
What does it mean by that? So is that our Boolean numbers?
Hey guys, hold on one second. Okay? Let me finish giving the assignment real quick. Example side, you also need to do 8 through 23 on the mixed side. Okay? Those are more just labeling sides or measurements out there. So that M, can I borrow yours real quick? So on this side, this says give me the actual angle measurement. That's what that M means. Okay? Guys, on 7 and 16, so what are you asking on 7?
Like, so when it says by the what is it like by the?
That's giving you your reason. Yeah, so by this theorem or this reason.
Okay.
So do your best on 7 and 16. Those are going to be kind of tougher ones. You're trying to break this one apart into a 2 column. So separate your reasons, your theorems and your reasons, your statements and reasons on 16. All right.